Hi, I'm Craig Smith, and this is Eye on AI. Currently, the largest AI system in the world is China's WuDao 2.0, a sparse, multimodal, large language model with 1.75 trillion parameters. It's trained on 4.9 terabytes of images and text. While not directly comparable to OpenAI's groundbreaking dense large language model, GPT-3, WuDao 2.0 is a more massive model, and what's more, much of its code is open source. This week, I talked to Tang Jie, a professor at China's Qinghua University who leads the WuDao team, about how the model was built, why it is unique, and what his team plans for the future. Connor Leahy, who was on the most recent episode of the podcast talking about large language models, joined me to lend his expertise in talking to Professor Tang. The audio is not always clear, and so I encourage anyone interested to read the transcript, which is available on our website, Eye on AI, that's EYE-ON.AI. I hope you find the conversation as mind-blowing as I did. Could I have you first introduce yourself, and then I'll have Connor introduce himself, and then we'll get to the questions. Do I call you Jie, or do I call you Professor Tang, or what should I call you?
Yeah, just call me Jie. My name is Jie Tang. I'm a professor in Qinghua University with the Department of Computer Science. I'm also the associate chair of this department. And my research interests include social network, data mining, machine learning, and knowledge graph, and of course, general artificial intelligence. Now, I just focus on the WuDao project. The WuDao project is a pre-training language model project. We have the ambition to pre-train the world data. I mean, all data, all kinds of the data. So we get data from China. Most of the web page, and also Wikipedia page, and the knowledge graph page. And also we get some data in English. So after cleaning, we have more than 1.5 terabyte cleaned Chinese text, not web page, but clean text, and 1.4 terabyte English text, and also 2 terabyte image. And recently we probably double the data, and then we'll pre-train another model. We have a team with more than 100 people working on that. And we have some very exciting new algorithm and also the model itself and many applications.
I want to introduce you to Connor in Germany. And he's with a group of unaffiliated researchers. And since he is familiar with language models much more than me, I thought it would be helpful to have him ask questions. Connor, why don't you introduce yourself?
I have a much less illustrious history than Professor Tang. I am one of the founders of a bunch of researchers interested in open source AI research and several other projects. We're most well known for our ongoing project to produce and release large open source language models, which is still ongoing. But we also do a bunch of other cool stuff.
So, when did the WuDao project start, and what was the motivation?
We started this project last October or maybe September. We want to build the largest pre-training model. I have the idea in Qinghua 3 years ago, which means 2018. I have the idea in mind. I want to pre-train all the data in the world. Last year, the end of September or maybe the beginning of October, we officially started this project.
Okay. Connor, why don't you go ahead with some of your questions?
Sure. Over here in the West, it's been a bit difficult to get details about the WuDao models. So I was interested if you could answer a few questions about some of the technical details. You decided to use the GLM training objective rather than a traditional LM or masked language model. I was wondering if you have tried LM or MLM and if you found any benefits of using GLM compared to these other architectures.
Yes, we actually have a paper on archive for the GLM. BERT is the auto-encoding model, and GPT-3 is the auto-regressive model. BERT is better at, for example, the natural language understanding, and the GPT-3 basically is better at generating something, answer some kind of question if you ask, for example, dialogue system or something like that. GLM basically unified all of this together, so it's a more general model. So you can use GLM for all the different things. So we have some tests for NLU, natural language understanding, and also generation, and even conditional generation. We get better performance. So that's the reason we want to promote the GLM model.
WuDao is a multimodal model. Could you elucidate a little bit how WuDao uses multimodal input and or output?
Okay, we actually use Chinese language and English language and also image. So we actually combine all the different things together. For example, you input some Chinese words and it can answer you in English in principle. And then, of course, you input English and it can answer you in Chinese. On the other hand, you can input, for example, Chinese, and the system can generate pictures for you. We have a demo for that. So you can input any kinds of words, any kind of words. For example, you can say, I want a picture of the cat with sunglasses. And the system will draw a cat with sunglasses. Of course, so DALL-E, released by OpenAI, can also do that. They verify that our performance can be much better.
I was curious how the architecture differs from DALL-E, if there's any specific difference.
It's totally different. Okay, to pre-train the model, we actually tokenize the image into different tokens, also combine the text and tokens together. All the code and the demo actually is online. If you're interested, you can try them and test their performance. It's quite open. The name of the system is CogView, CogEW. So in that system, we actually did some super resolution, which means we first generate some kind of token, like in node, and then we up sampling to generate super resolution. So the performance is quite good. And we actually use this one to inversely generate an image caption. And to do the ranking, the DALL-E generated 16 images and select which one is the best and choose the best one. But we only generated 8 images. And we use inverse image generation. In that way, we actually can generate very perfect images. We also did something for some specific domain. For example, we collaborated with Alibaba to generate some image using GAN in that domain. That performance is super good. You actually cannot distinguish it's a real picture or not, or generated one. So we actually quite different from DALL-E. We have some technical contributions. So for example, the auto-regressive transformer, like the transformer itself. We also have precision bottleneck relaxation, PB relax, which makes the model generate more stable. Second is the sandwich layer normalization. We call it sandwich LN. That can also make the model much more stable. So if you check our neural IPS paper, you will see that we are working on to generate video. We have the first version. Hopefully we can generate video using text based on that.
Wow, very impressive. What is the plan with WuDao? Do you plan to continue to scale these types of models? Do you plan to release some kind of commercial application, release the model to researchers? What's the plan?
We do have the plan to continue increase the scale. For example, maybe 10 terabyte and 100 terabyte. I have to tell you that in June, we actually already trained the 100 trillion parameter models.
Wow, that's incredible.
It's not convergent. We didn't train the model until convergence. We just proved that we have the ability to do that. So that is our plan, but it's not urgent. We can do that quite easy. We have a supercomputer. We can do that. It's in our plan. It's in our schedule. We actually want to do some application. So we build an association with more than 30 big companies in China. We hope that we can use the model to build some application to help them with millions or even billions of users. So that is more urgent for us because we do want to show the benefit of the model to all the users and also, of course, to all the readers. So that's the second plan. And the third plan is that we do hope that we can build some novel models. So, for example, we want to generate video. So that actually is quite new. The OpenAI, they didn't do that. And also, we hope that the generative result could be correct. So, for example, like GPT-3 and GPT-2, they generate text and image, but actually most of the generative result is not correct. It's just like a bullshit sometimes, right? It's the same here. So we hope that we can combine knowledge and the model itself together and maybe double check and make the generative result more accurate. We cannot make sure that it's correct, but at least more accurate. That is very important to us. And also we are working on fine-tuning the model. We call it P-tuning tool. So this algorithm, we already published this paper, and also we have the code available. The P-tuning with less than 1% of the data can fine-tune the model better. So only 1% of the data. So that gave another direction, or a totally new direction, because fine-tuning is very important for the pre-trained model. And we are working with some chip company, and we hope that we can build a new underlying architecture for the big model. So that's another thing. So working for that. So ideally, finally, we hope that we can make this model do something beyond the Turing test. That's our final goal.
On the number of parameters, so 10 times more parameters than GPT-3, but how do you measure its performance compared to GPT-3 and DALL-E? You've given some benchmarks, but do you generally consider it twice as capable or twice as useful, 10 times as capable or useful? How meaningful is the parameter metric?
Compared with DALL-E, they did some kind of evaluation on MS Coco, and they using the metric FID. We did the same thing, and our performance is clearly better than them. And second, we put it online. We can generate a picture in less than 1 minute. It's quite open. The performance is quite clear, much better than DALL-E. So you can test it, but the demo itself only supports Chinese language. But for the first one, for the evaluation, we did that in English, comparing with DALL-E using MS Coco. For WuDao system, comparing with GPT-3, we didn't do that because we cannot get the API. So we can only test our method on our machine using our data. And also we have English and Chinese and also image. They only have English as far as I know.
Is there a plan to release a public API or a licensed API?
We do have the plan, but it probably will be later because it's expensive to host the API. We already have many partners in China. They just use a hard disk and copy the model to their company. The reason is that the model is too huge and we do not want to host it.
And if scale is the differentiator for these models, what do you see as the limit for model size?
We already published more than 20 models based on WuDao. We published those models and also API for those smaller models. That's quite open. You can just go to the website and check the model. Chinese and English, and also API, we send some kind of request and access the model. You can easily do that. But for the largest one, as I said, it's difficult to host that because it's simply expensive. But in the future, we will do that.
The hardware that you're training this on, you're using the Sunway supercomputer, is that right?
Yeah, same way. The largest supercomputer, the largest. For those smaller models, like 10 billion and 100 billion, we train just a normal GPU architecture.
You've talked about pre-training the world. Is WuDao 2.0 training ongoing? And is there a lifelong learning element to this? And does that mean that this podcast will find its way into the pre-training data?
Yeah, very good questions. We do have the plan to build something like a lifelong learning system, which can pre-train all the data continuously, continue to improve the model. But we didn't train the largest one, just as I said, 100 training model, but we didn't start that one because we want to find something novel, some kind of new algorithm to do that. So we'll still do some research on that.
Just generally, China's AI research is advancing rapidly. What direction do you think is likely to lead to a breakthrough? And maybe what you just said.
I don't think we are very strong. We are still learning from experts from United States and learn from experts from Europe. But at least they just work hard. So just every day, probably 12 or maybe 14 hours, we just work. We generate so much data. We have more and more data. So maybe we can leverage the reach of the data and build maybe a larger model.
Looking forward to the future, do you expect to see human level or superhuman level, even intelligence in our lifetimes?
Yeah, that's quite a good question. Personally, I think after 10 years or maybe 20 years, 10 to 20 years, I believe that machine, the AI, can do better than human being in terms of most of the cognitive tasks, like writing, like speaking. If the task can be described into some kind of computational models, after 10 to 20 years, that is a generation of cognitive AI. I'm quite sure about that. So that's cognitive science, cognitive task, the machine will beat human being. After 50 years, I believe that the machine will have consciousness. We will have entered into a new world and we will live with machine.
Some prominent figures recently, such as Stuart Russell from UC Berkeley, have expressed some concerns about these kinds of things. They think that building extremely powerful human or human plus level super intelligent machines without any way to control them might be very dangerous. Even now, our agents and stuff do all kinds of bad things. We give those things superhuman powers, and that sounds very dangerous for the human race. Do you consider these risks?
Yeah, this is very important. We should have some kind of policy to control that. On the other hand, it's about the science. So we should also say that if it is possible, or can we really do that? If we cannot do that, why should we worry about that? If we can really do that with science, of course we should worry.
Do you think it would be better if governments intervened more in research or regulated research or hardware more? Do you think there's some kind of possibility for international treaties, or do you think this is the wrong direction?
Yeah, I believe that the government should do something for that. Not for pre-trained model, but for general AI. Because we are facing the generation of general AI, generation of cognitive AI. AI will probably be potentially dangerous to human beings.
Do you think that's likely that maybe the governments can come together? Do you think that's possible?
Yeah, I think it's possible.
You were at Cornell, and the head of BAAI was at Microsoft, and Baidu has a research center in California. So there's a lot of cross-pollination, but at the same time, the two governments are working on developing military capabilities. The research community is collaborative and it works across borders, but the governments are trying to take that research and they're not collaborative. Do you worry about that? How do you see that playing out?
I'm quite positive. Personally, I'm quite positive to the situation. I'm quite positive to the science. Definitely cutting the collaboration between China and the United States will at least delay the research in China because we do not have powerful chips. We are quite open, actually. I'm leading the team with more than 100 people, and we build all the different models. We just release all the models, make it open to the world, to all the world. People can access the API because it's just science. We build science for all the human beings in the world. We want to build some kind of model which can benefit all the people. Even with such kind of serious situation, I still believe that we could do even better than GPT-3. I define 3 stages. Stage 1, we follow GPT-3 and follow DALL-E. Stage 2, from now or the beginning of next year, we will do something special. And in some part, we will be better. And some part probably not so good, but we will build something comparable with OpenAI. And stage 3, of course, we hope that we can build the best. That's an ambitious goal. Such kind of science is not for China, it's actually for all the world.
Is the entire WuDao source code on GitHub? Is the entire model public or just parts of it?
A few parts is not open because we also have some code on the supercomputer. You cannot use that code on the normal computer.
So this competition between China and the US, it's a government competition, but it's a collaborative competition among researchers globally. It's more of an adversarial competition among governments and militaries. How do you handle that? Hopefully it won't lead to decoupling of the research communities, but I know in the US there's a lot of pressure on the private sector, on research institutes to cooperate with the military. A lot of the funding comes through DARPA. On the Chinese side, certainly a lot of the funding comes from the government. What choice do researchers have to avoid this adversarial relationship?
To this question, different people will have different answers. Myself actually learned a lot when I visited United States, like IBM and Microsoft. I learned from United States. One coin has 2 sides. From the science, purely science, I only want to do something to advance the science. So we hope that we can do some science for the world, not just one country. On the other side, that is national research, which means we should do something on demand. So that's based on the national project research plan. This is probably the same for all the people in the world.
You mentioned working on a novel algorithm, a new algorithm. Can you talk at all about where in the stack that algorithm will fit? Is it something like mixture of experts to help training, or is it a more basic algorithm like the transformer algorithm?
Yeah, that's a good question. It is still on stage 1. So we are still working with the transformer system, transformer algorithm, and we use MOE, so mixture of expert. Actually, last year, when Google published MOE, we actually already have the code. We also want to publish that paper, but Google released that paper. We have no chance to publish it. So we developed the open source code. We call it fast MOE. So the code is totally open source on the website, and it's much faster than the MOE by Google. That new algorithm actually underlines still transformer architecture, but the mechanism is different.
Thank you so much, Jie. This has been really helpful, and it's really nice to see the optimism on your side. And I just really hope your research goes well and that we can continue to collaborate as a global science community.
That's it for this week's episode. I want to thank Professor Tang and Connor for their time. As I said at the outset, you can find a transcript of this episode on our website, eye-on.ai. I'm interested in hearing your thoughts on large language models, so please email me any comments at Craig, C-R-A-I-G, at eye-on.ai. And put listener in the subject line so I don't miss your email. Remember, AI is about to change your world, so pay attention.